Somewhere right now, a dealership is charging someone $180 to fix something that costs $2 and takes 8 minutes. And that person is probably nodding, handing over their keys, and walking to the waiting room with the little paper cup of bad coffee. Because nobody told them what I'm about to tell you. Foggy headlights. That dull yellowed, oxidized plastic that makes your car look 10 years older than it is. That cuts your nighttime visibility by as much as 80%. That, every single time you walk up to your car in a parking lot, makes you feel like your vehicle is slowly dying. Auto detailing shops have built a $400 million annual industry in the United States around the idea that fixing this is complicated, that it requires equipment, expertise, multiple stages of sanding, polishing compounds with brand names on the bottles. The truth is so simple it's almost insulting. The headlight restoration market is worth over $400 million a year in America. And almost all of it is built on one single fact that nobody in that industry wants you to verify. That the compound responsible for most of the hard work in high-end professional restorations costs less than $2 in its raw form, has been used industrially for over a century and requires no sanding, no drill attachment, no buffing wheel. Just the compound, a cloth, and about 8 minutes per headlight. Before 1989, headlights were made of glass. And glass doesn't fog. It scratches, it chips, but that deep uniform oxidation haziness you see on virtually every car made in the last 30 years, that doesn't happen to glass. That phenomenon is specific to polycarbonate. In the late 1980s, automakers switched from glass to polycarbonate plastic for headlight lenses. It was lighter, it was cheaper, it was more impact resistant. It could be molded into those aerodynamic curved shapes that glass couldn't hold. The trade was that polycarbonate is vulnerable to UV radiation. Left unprotected, it oxidizes. The outer layer breaks down over time, forming a microscopic layer of degraded, cloudy plastic on the surface. From the factory, manufacturers apply a UV protective coating that delays this by 4 to 6 years. But once that coating wears off, from sun exposure, from car washes, from road grit, the countdown starts. And it's not just cosmetic. The degradation you're looking at is a surface phenomenon. It's happening in the outer 200ths of a millimeter of that lens. The underlying polycarbonate is almost certainly still perfect. Optically clear, structurally sound. What you have is a surface contamination problem, not a material failure. That distinction matters because it means you don't need to remove material to fix it. You need something that addresses the oxidation layer chemically and optically without eating into the good plastic underneath. This is where the detailing industry makes its money on misdirection. Most headlight restoration kits on the market tell you to sand. They give you 400 grit, 800 grit, 1200 grit, 2000 grit, sandpaper in escalating stages. And sanding does work, in the same way that demolishing your kitchen works if you want to fix a chipped tile. You're removing material. You're cutting away the degraded layer, but polycarbonate is soft. You're also creating thousands of microscopic surface scratches at every sanding stage that you then have to remove with the next finer grit. And here's what the kit instructions quietly omit. Sanding removes the UV protective coating from the surrounding lens area permanently. So you fix the oxidation, you restore clarity, and then 18 months later, it's back. Because you sanded away your protection. The kits know this. That's the business model. What is this compound that works so well the detailing world quietly repackaged it behind a brand name and a $40 price point? It's called cerium oxide. And before the auto detailing industry discovered they could put it in a tiny branded bottle and sell it as part of a 10-piece headlight restoration kit, it was sold industrially in bulk for pennies per application. Cerium oxide is what's called a polishing abrasive, but at a nanoscale level that's fundamentally different from sandpaper. It doesn't scratch and scrape. It works through a chemical-mechanical process. The cerium oxide particles bond momentarily with the silica in the polycarbonate surface and carry away the oxidized material at the molecular level while simultaneously smoothing and clarifying the surface beneath. Glass manufacturers have used it for over a century to polish optical lenses, telescope mirrors, camera lenses, precision optics where surface clarity is measured in billionths of a meter. This is not new science. It's been in industrial applications since before World War I. Here's what that means for your headlights. You don't need to sand because you're not mechanically removing a layer. You're using a chemical process that selectively addresses the oxidized material without creating a new layer of scratches to fix. And because you're not abrading the surrounding lens, you're preserving whatever UV coating is still in place elsewhere on the lens, rather than grinding it off. You can buy cerium oxide powder at any lapidary supply store, any glass and ceramic supplier, or online. You want cerium oxide at roughly 99% purity, particle size in the range of 1 to 3 microns. That's the standard polishing grade, not the coarse abrasive grade. It costs somewhere between $4 and $8 for an amount that will restore 12 to 15 headlights. Some hardware stores stock it. If yours doesn't, it ships cheaply. The compound itself is the entire purchase. You don't need a kit. Mix roughly 2 teaspoons of the powder with enough water to form a paste. Think of the consistency of toothpaste. Not watery, not thick like clay. Something that spreads smoothly and stays on the surface. Warm water works slightly better than cold because the chemical activity is mildly temperature sensitive, but this isn't precise. Room temperature works fine. Take a clean microfiber cloth, apply a generous amount of the paste, and begin working it into the headlight surface in circular motions. You don't need pressure. You need coverage and contact time. The reaction isn't happening through force. It's happening through the chemical bonding between the cerium ions and the oxidized surface layer. Moderate, consistent pressure. Circular motions. Cover the whole lens. Work each headlight for 3 to 4 minutes. You'll see the paste turn slightly gray or brown as the oxidized material lifts off. That's exactly what's supposed to happen. That's the contamination leaving the surface. Wipe clean with a damp cloth, then a dry one. Look at the lens in good light. If there are still hazy areas, repeat. Most lenses need 2 passes. Heavily oxidized headlights might need 3. Each pass takes 4 minutes. At no point are you sanding. At no point are you removing good material. Here's the part that most write-ups skip: sealing. Cerium oxide restores clarity, but it doesn't restore the UV coating that originally protected the polycarbonate. Without sealing, the oxidation will begin again. Slower than it would on a factory new lens, but it will start. There are 2 easy options. The first is a UV-resistant spray clear coat, available at any auto parts store for $4 to $6. 2 thin coats, let it cure for 24 hours, done. The second option, which I found works just as well for the first 1 to 2 years, is a film of carnauba wax, the same wax you'd use on your car's paint. It's not a permanent UV shield, but it slows the reoxidation meaningfully, and you likely already have some. If you want the best longevity, use the clear coat. If you want a maintenance approach, reapply wax every few months as part of your normal car care. Either way, you're extending the life of your restoration. What you end up with are lenses that are optically comparable to a professional restoration, sometimes better, because you haven't removed material with sanding. The clarity comes back, the yellow goes away, and the actual cost involved, start to finish, is somewhere between $2 and $8 depending on whether you already have microfiber cloths and wax. You now understand more about headlight degradation chemistry than the person behind the counter at any detailing shop is likely to tell you, because their job is to charge you for the service, not explain why the service is trivially simple. That's not cynicism. It's just how service industries work. The knowledge exists. It's been in industrial chemistry for over 100 years. The compounds are not secret. They're just not in the section of the hardware store where people looking to fix headlights tend to look. If this kind of buried practical knowledge resonates with you, the kind where understanding the mechanism means you can stop paying someone else to apply it for you, subscribe and you'll see more of it. And if you know someone who just got quoted $150 at a shop for their headlights, send this to them first.